Okay, this question is related to counting rules. So we have three sub-questions here. This question is bigger. It has actually 6 parts, but you will see the other parts in other videos. Because if I solve the 6 parts in one video, it would be a very long video. So I chose to solve the first 3, A, B, and C, and then D, E, and F. Each of them will have a video of its own. Okay, so let's start with the first one. How many different ways can 8 speakers be seated on a stage? Okay, it's written on the second page. So let's go to the second page. The question is here. And I remind you of the fundamental counting rule. So you can read the rule. I will explain it to you while I'm solving the question. So how many different ways can 8 speakers be seated on a stage? So you'll have 8 seats. Let's put them here. 1, 2, 3, 4, 5, 6, 7, 8 seats. And then you ask yourself, how many possibilities are for this seat? Well, you can put any of the 8 speakers here. So we have 8 possibilities here. Now, once a person is chosen already, how many possibilities now are left for the second seat? You can see 7 speakers are left. And then after that, it will be 6 possibilities, 5 possibilities, 4 possibilities, 3, 2, and 1. And if you read the fundamental counting rule, it says that you multiply the possibilities for each one. So what we will do is we will multiply these numbers from 8 down to 1. And if you remember, this has a mathematical symbol. We call it 8 factorial. Remember that n factorial is equal to n times n minus 1 times n minus 2, and you keep on going down until you reach 3 times 2 times 1. So you go all the way down from your number until you reach 1, and you multiply everything. This is the factorial. Okay, so just one thing is, what is 8 factorial? If you calculate it on your calculator, you should get a very big number actually. It's 40,320 possibilities. Imagine, you have these possibilities for seating 8 people. Okay, so this was A. Let's go to B. But before I go to B, remember that this table will be used for A, B, and C, the fundamental counting rule. So in B, the question is, in fact, it's kind of a simpler question. You just need to pay attention. It says, how many different 3-digit identification tags, 3-digit identification tags can be made? And look at the condition they're giving you. They say, if the digits can be used more than once. So it means that you can use the same digit more than once. So first you draw 3 boxes. Each of them will have one of the digits. So first you ask yourself, how many possibilities for the first digit? You know, it could be any number from 0, 1, 2, 3, up to 9. And this gives you 10 possibilities. From 0 to 9, count, you'll have 10 numbers, or 10 possibilities in this case. Similarly, since here they said the digits, look again, the digits can be used more than once, it means that I can also choose from 0 to 9 on the second one, so I have 10. And on the third one, I have 10, because all of them can be used more than once. All of these digits can be used more than once. And if you go back to the fundamental counting principle, what you do is you multiply the possibilities. So here we have to multiply these numbers, and the total number of possibilities will be 10 times 10 times 10, which is 1,000. 1,000 what? 1,000 possible 3-digit identification, let's say ID tags. And between parentheses here, so the answer is 1,000, yeah? Between parentheses, I would just remind you that digits can be used more than once. More than once. And that's why we got 1,000. Now, keep this one in mind and look at the next question. The next question is the same exact one. How many different 3-digit identification tags can be made if, look at now the condition, if the first digit must be a 5 and repetitions are not permitted. So let me give different colors for this. The first digit must be a 5 and repetitions are not permitted. And of course, you remember that it should be a 3-digit identification tag. So again, you draw the 3 squares to put all the possibilities in them. Now, for this first one, you look, it says here, the first digit must be a 5. So I have only one possibility. The number 5 is the only possibility that I should put here. So there is one possibility. Okay, and now repetitions are not permitted. You read again, repetitions are not permitted. So this means that for the second one, I can use the digits 0, 1, 2, 3, 4. I should skip 5 because I cannot repeat it. 6, 7, 8, 9. And if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, you have 9 possibilities here. And the last one here, it cannot be a 5 and it cannot be the one that you chose from here. So you chose one, let's just say, it could be any of them, but let's say that it was the 2 that you chose. So for this last one, the possibilities would be 0, 1, 3, 4, 6, 7, 8, 9, which are altogether 8 possibilities. And just know that this choice of 2 is random. It can be anything. What matters is that whatever you have chosen here, you cannot repeat it there. And because we had a 1 possibility for the first digit, it must be 5. We were given that. Now we multiply these numbers by the fundamental counting rule. And so this will give you 1 times 9 times 8, which is, of course, very easy. It's 72 possible 3-digit identification tags if the first digit is a 5 and repetitions are not allowed. Okay? I hope that you understood this question now.